Hello class, welcome to Geometry Lesson 4.4, which is all about proving and applying the ASA, which stands for angle, side, angle, and the angle, angle, side, or AAS congruence criteria. By the end of this lesson, you should be able to determine congruent triangles by comparing two angles and one side. So let's start by talking about the angle, side, angle congruence criterion. So if we have two triangles and we have angle, side, angle, that means that I need to have two angles, and between those two angles, I have to have a side. So the side has to be included. It has to be between those two angles. And if I look at these drawings, on both of them, my side is included between the two angles that were given. That's called the angle, side, angle, or ASA, is what you'll see me abbreviate it to. The second theorem that we're going to talk about today is the angle side congruence criterion. That means that I have an angle, then I have another angle, and then I have a side. Okay, so I have angle, angle, side. That is our AAS congruence. Now, let it be known that it's easy to mix up all of these four acronyms, but the one that I can promise you will never occur is I will never ask you to write a bad word on your paper. That does not occur, okay? So we have angle, angle, side. We have angle, side, angle. And yesterday we had side, 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 and side, angle, side, okay? So those are our four. Now, let's look at these groups of triangles, and we want to state whether these triangles are congruent. And if they are, we want to state which theorem proves that they are congruent. Okay, so if I start with our first set of triangles, I see that I have an angle, and then I have a side, and then I have another angle. So are those congruent? Do we have an angle, side, angle? We do. That's something that we just talked about. So these two are congruent by angle, side, angle. Number two, I see I have a side, another side, and then I have a third side. So are these congruent? Yes, by side, 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 or SSS. Our third group of triangles, I have an angle, I have another angle, and then across from that angle I have a side. So I want to look and see, does this meet the criteria? So I have two angles in a row and then a side. Two angles in a row and then a side. So is that one of my options? As far as two angles go, I have to choose between angle, side, angle, which that would tell me that my side was between my two angles, so it can't be that one. Does it meet the criteria for angle, angle, side? Let's see. Angle, angle, side. So yes, this is the AAS theorem. All right, let's look at this next one. I have a side, and then I have an angle. If I look, that angle is between my two sides. Whereas over here, that angle's not between the two sides. I would have to have this angle in order for these to be congruent. So these two are not congruent. Okay? Now, if I give you this picture and I want you to prove that angle B is congruent to angle D, let's see if we can use one of the theorems that we learned today. So either angle, angle, side, or angle, side, angle. And what I'm going to do is I'm going to write a two-column proof. So I'm going to write down statements and reasons. And if I look at my picture, I can find my given information. So this is the same picture as yesterday, but we're going to prove this information a little differently. So my given, I see that I have two congruent sides. So I can say segment AB is congruent to segment DC, or actually, I'll put CD. And then I also have these arrows. They might be hard to see in your video, but they're there on the picture, okay? So that was given information. And those arrows, remember, tell me that two things are parallel. So I can also say that segment AB is parallel to segment CD. And this is all given in the picture. Then I want to look at that picture. I want to think, if I'm trying to prove that angle B is congruent to angle D, let's see. I want to prove that these two angles are congruent. Well, in order to do that, I am going to have to prove that the triangles are congruent first. Okay? So, in order to prove the triangles are congruent, I can look and say, well, I already have a side. And then let's try to see if I can find two more angles that I can prove. So if I look, I'll highlight this triangle green, and then I'll do the light blue. I'll call that light blue. Okay, so if I am trying to prove that those two triangles are congruent, I can look and say a few things about the angles. If I have parallel lines, I know I have angle relationships. So I want to look and say, what angle is this red one congruent to? Well, it would be congruent to this angle over here, because it would be considered, here's my parallel lines, here's my transversal. That would be alternate interior angles. So I'm going to call that angle DAC. I'm going to say it's congruent to angle BCA by alternate interior angles. And then I can look at the picture and say, well, another angle that would be congruent would be these purple angles by the same thing, right? They are still alternate interior angles. So I could say angle BAC is congruent to angle DCA. Again, that's alternate interior angles. So now I have two angles and a side. So I have to figure out which of these two I am using. So I have angle, angle, side. Angle, angle, side. Should have started the same order. So what I can say is that triangle ABC is congruent to triangle CDA by angle, side. Now that I know they're congruent, this is where we talked about this briefly yesterday, where if two triangles are congruent, that means everything about them is also congruent. So I can say that angle B is congruent to angle D, and this is using the cpctc theorem. Remember, the corresponding parts of congruent triangles are congruent. I know it's a mouthful, but whenever you are given a picture with two, in this case it's triangles, but two shapes that are exactly the same, and you're trying to prove that an angle is congruent to an angle or a side is congruent to a side, 99% of the time you are going to prove that those two figures are congruent first. In this chapter, that means you're going to use angle, side, angle, angle, side, 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 or side, angle, side. You're going to use those first to prove that your figures are congruent, and then you will use cpctc to say that the corresponding parts on the, cpctc is specific to triangles, but you'll use that to prove that any angle or any side is congruent on the two figures. Now, let's try another proof. So we want to prove that segment FH is congruent to segment JL. So we are given that GH is congruent to KL. So let's write that down. First, I'm also going to move that just a little bit closer. So if I start, I can write segment GH is congruent to segment KL. Angle GFH is congruent to angle KJL. And I can say angle FGH is congruent to angle JKL. And this is all given. Then, so if I look at that, I'm just going to highlight this a little so it's easier to see. I was just given a lot of information, right? And if I look at my picture, I see I have an angle, angle, side, angle, angle, side. So I can say right off the bat that triangle if I could write my letters, triangle FGH is congruent to triangle J. Wow. My letters are terrible today. Sorry, guys. JKL. And that is by angle, angle, side. Now that I know that those two triangles are congruent, what can I say about another side on those triangles? Just like I talked about in the last proof, and I finished the last proof with this, I can say that all of the corresponding parts are also congruent. So I can say, if those two triangles are congruent, then segment FH has to be congruent to JL. And that's why the corresponding parts of congruent triangles are congruent, or cpctc. And that's all I have to do for that proof. I am done. So the quick concept summary, you have angle side angle and angle angle side. You'll use these along with everything we learned yesterday. And if you have any questions, please feel free to reach out for help, and I'm happy to help you. Have a great day.